Hello students, I have a problem here on divergence of D. In this problem, the vector D is given in three different coordinate systems. Let us see how to find the divergence of D. Okay, let us start with the part 1. The vector D is given in Cartesian coordinate system. So, the divergence of D vector is given by the equation dou by dou x of dx, dou by dou y of dy, and dou by dou z of dz. Divergence is a scalar operation, so there are no unit vectors. So to find the divergence, we need x, y, and z components of D. So in the problem, dx is 1 by z square into 10x, y, z. So after simplifying, you will get 10xy by z. Similarly, copy all the three components of D. dy is 1 by z square into 5x square z. The same way here, 1 z cancelled, 5x square divided by z. The z component is 1 by z square into 2z cube minus 5x square y. This can be simplified as 2z minus 5x square y divided by z square. So you have noted down the three components of D. Let us put these components into the equation of divergence. Then divergence of D becomes dou by dou x of dx. So dx is 10xy by z. Dou by dou y of y component, that is 5x square z. The last one is dou by dou z of z component, 2z minus 5x square y divided by z square. Now we have to carry out these partial differentiations. The first one is with respect to x. So differentiation of x is 1, 10y by z is constant. 10y by z is constant. Differentiation of x is 1. Then in the second differentiation, this is with respect to y, but there is no y term here. So 5x squared by z is a constant with respect to y. So the differentiation of a constant is 0. And the last term, first we have 2z. Differentiation of 2z is 2 with respect to z minus. In the last term, we have 5x square y is constant. So we have to differentiate 1 by z square. So differentiation of 1 by z square can be easily done by taking z square to the numerator. This becomes z power minus 2. So differentiation is minus 2 z power minus 2 minus 1. This gives us z power minus 3, which can be written as 1 by z cube. So here we are having minus 2 divided by z cube. Finally, we have the answer of 10y by z plus 2 minus 5 minus into minus plus here So minus into minus plus 5 into 2 can be taken as 10 x square y divided by z cube. This is the divergence of D vector given in the problem. But the divergence is asked at a specified point. Let us see what is that point. The point is minus 2, 3, 5. So whatever the answer we got is the divergence of D at any point. Specifically at a point P of minus 2, 3, and 5. So divergence of D is given by 10. Y value. See, in the point XYZ components are mentioned. So according to that point, Y value is 3, Z value is 5. Plus 2, 10. X square is minus 2 square. Into Y is 3 divided by Z cube is 5 cube. So using calculator, we can find divergence of D at the specified point, and we get 8.96 coulomb per meter cube. So in summary, we use the formula in terms of partial differentiation for divergence of D. Then we carry out the differentiation. Then finally, we enter the coordinates of the point given. Now we'll repeat the same thing for part 2 of the problem. So the problem is taken here. Let us try the part 2. See this problem, the part 2 of the problem is in cylindrical coordinate system because there is only one angle. One angle means cylindrical coordinate system. So in the cylindrical coordinate system, we have the variables rho, phi, z. So phi is the only angle here. So based on this only one angle, we can declare that the D vector is described in cylindrical coordinate system. But instead of rho, R is used. So R and rho can be interchangeably used in cylindrical coordinate system. So that's why first, let me list the components of D. First one is dr, the R component of D is phi z square. And there is no phi component given 0. Z component is given there as 10RZ. So the three components are copied. Now it shall go for the formula for divergence of D, which will be equal to 1 by rho, now will be written as 1 by R. Dou by dou rho can be taken as dou by dou R, R into dr. Next 1 by rho becomes 1 by R, dou by dou phi of d phi, and dou by dou z of dz. This is what the formula to find the divergence of D in cylindrical coordinate system. So in this case, the phi component is 0, 0. That's why the complete differentiation of second component is 0. So if we continue now, 1 by R, this term 1 by R is outside the differentiation, so don't change it. We have to carry out the differentiation of the terms within the bracket only. So R into dr. dr is 5z square plus this middle term 0. The last one is dou by dou z of dz. dz is 10RZ. So it's a very simple differentiation. Here 1 by R. Differentiate the terms within the bracket with respect to R. So 5z square becomes constant. Differentiation of r is 1 into 5z square plus last one is with respect to z. So 10r is constant. Differentiation of z is 1. So finally, we have the terms 5z square by r plus 10r 5z square. Here z value. So we have to find the components of the point required. So first let me write the point P at which we need to find divergence. If you look into the formula, 3 minus 45 degree and 5. There's a point given. So at the point P of 3 minus 45 degree and 5, we have to find the divergence. So here 3 is R, minus 45 is 5 and 5 is Z. So div D becomes 5 into Z square. So nothing but 5 square divided by R. R is nothing but 3 plus 10 into 3 will be 71.667 coulomb per meter cube. This is what is the divergence at the given point in cylindrical coordinate system. Similarly, let us look into part 3, in which the vector D is given in spherical coordinate system because there are two angles given in the problem. So there are theta phi. So in the same way, we shall separate the components. The r component is 2r sine theta sine phi. Theta component is r cos theta into sine phi. So phi component is r cos phi. The three components are ready. Now we have to go to the formula. Divergence of D in spherical coordinates is given by 1 by r square dou by dou r square dr plus 1 by r sine theta dou by dou theta sine theta into d theta 1 by r sine theta dou by dou phi d phi. This is the formula for finding divergence of D in spherical coordinate system. Now the divergence becomes is equal to 1 by r square dou by dou r of r square into dr. Dr is 2r sine theta sine phi and the second term 1 by r sine theta dou by dou theta of sine theta into d theta. Second term d theta is r cos theta sine phi taken from here into Now the last term, 1 by r sin theta, dou by dou phi of d phi, that is r cos phi. Okay. Now div d is equal to, so let us differentiate. The first term to be differentiated with respect to r. 1 by r square being outside the differentiation, no change. So here we have to differentiate only r terms. So r square into r is r cube. So differentiation of r cube is equal to 3r square. So okay. So here we get 3r square after differentiating r cube. Then you are left with 2 sin theta sin phi are constants. Plus in the second term, 1 by r sin theta is outside the differentiation, no change. And here theta is the variable, so sin theta and cos theta to be differentiated. R and sin phi are constant. So what we shall do, we shall differentiate this one using product rule, UV method. Okay. So according to the product rule, first we shall keep sin theta as it is. First differentiate cos theta. Differentiation of cos theta is minus sin theta. Plus, now let us keep cos theta as it is, then differentiate sin theta. Differentiation of sin theta is cos theta. Now what are the constants here? R into sin phi. They will be present as they are. Finally, 1 by r sin theta. Now differentiate with respect to phi. So r is constant. Differentiation of cos phi is minus sin phi. So let us simplify. Div d is equal to, here r square cancelled. 3 into 2, 6 sin theta sin phi. The second term, r are cancelled. So we have sin phi term, denominator sin theta term, and here it is minus sin square theta plus cos square theta. Lastly, here also are cancelled. We have minus sin phi divided by sin theta. So divergence is ready. We have to find divergence at the point specified. So in the problem, the given point is 345 degree and minus 45 degree. Here 3 represents our 45 theta minus 45 phi. So divergence becomes now is equal to 6 sin theta, so sin 45 degree, into sin phi, sin minus 45 degree, plus sin phi, sin minus 45 degree divided by sin theta, that is 45 degree, into minus sine square 45 degree plus cos square 45 degree. So the last term is minus sine 5. So sine minus 45 degree divided by sine plus 45 degree. Now we know that sine 45 degree is 1 by root 2. Cos 45 is also 1 by root 2. And sine of minus 45 degree is minus 1 by root 2. This 1 by root 2 can also be taken as 0.707. So now the divergence of D becomes 6 by root 2 minus 1 by root 2. From the first term, then minus 1 by root 2 in the numerator plus 1 by root 2 in the denominator minus sine square theta. 1 by root 2 whole square, nothing but 1 by 2 and cos square. 1 by root 2 whole square is 1 by 2. So in the last step, same way, 1 by root 2 minus in the denominator, 1 by root 2 plus in the numerator. Sorry, denominator. So here we have minus 6 by 2. Plus half and minus half cancel to 0. And here also 1 by root 2, 1 by root 2 cancelled, we'll get minus 1, minus into minus, plus 1. So we'll be having an answer of minus 2 Coulomb per meter cube. So this makes the solution of the problem given.